think? So the first question says a tiny pencil mark just visible to the naked eye contains about 3 times 10 in power 17 atoms of carbon. What is the mass of this pencil mark in grams? All right, so let's just think how to approach this question. So what do we have is number of atoms of pencil mark. That's it. This is what is given. We need to find what is the mass of this amount of atoms of carbon. Okay, so this is what we need to find out. So what do we know from from the previous classes is that we know that 1 mole of carbon is 12 grams, right? At the same time, we know that 6.022 times 10 in power 23 is also 12 grams because 1 mole is the same as this amount of elements, right? Or units, let's say like that way. So now we need to find what's going to be the mass of this amount of carbon. This is what we need to find out. So I have a question. How do you think it's going to be more than 12 grams or it's going to be less than 12 grams?
Less than 12 grams.
Less.
Obviously, it's going to be less than 12 grams. Now let's just find out how less it's going to be than 12 grams. So we already know that this amount is 12 grams. So then we can just simply write times 17 is going to be x grams, right? So this is what we need to find. Can somebody calculate x? Oh.
Is it 4.98 grams?
4.98 grams. I don't think so because what I see here is that I don't think that this is the right one because I see from the very beginning that see how big is the difference between powers here. So it's basically 1,000 times more than this. So 10 in power 23 over 10 to power 17, it's I can tell you it's 10 in power 5. So it cannot be this much. So you got basically almost, well, two times, I would say 2.5 times less than 1 mole. I don't think that it's a right answer. I'm not really sure because I don't know. I'm calculating with you, but what I see from the very beginning, my expectation cannot be like this much. Can you recalculate it?
I think it's 2.007.
No. So grams? What is the unit?
Gram.
Yeah, so you said 2 point something, right?
007.
Okay, 007. Again, I think it's too much. What you guys are doing actually, it's very simple calculation, but I'm not very sure if you are approaching right. So this is not right. I don't think that this is also right. I don't think so.
Doctor, 0.49 or 0.5.
Okay, so let's just see what is this answer. Okay. So we need to calculate x, right? So we need to calculate x. How we calculate x? Actually, we can just do cross multiplication. It's like 12 times 3 times 10 in power 17 divided by 6.022 times 10 in power 23. Okay, so this is 36. I can just tell you now. So this is 36. 12 times 3, it's 36. 36 divided by 6.022, it's approximately 6. Let's say put 6 over here. Okay, now we need to divide 10 by 10 in power 17, 10 in power 23. It's going to be 10
minus 6.
minus 6, right? Okay, so this is what is the amount of pencil mark, which is, well, okay, so there are some answers, but I cannot read them. I'm sorry about this. So
Sir, can you repeat from where did you get the 12?
Okay, so this is from here. So you just do cross multiplication. You multiply these by this and this by this. Okay, guys,
Yeah,
you are answering here in the
12
chat.
grams?
I'm sorry. So you are answering in the chat, but I cannot understand it because, you know. Say it again, please.
How did we get the 12 grams?
So this is what I'm saying, that we know that 1 mole of carbon is 12 grams, which means that 6.022.
So it's the molar mass, right?
It's a molar mass. Yes, it's a molar mass. So we know that this is 12 grams. So then we need to find out the rest. Okay. Did you guys
But
follow?
isn't
Doctor,
but
Yes.
to find the
Yeah, just, you know, we can discuss. If it is wrong, we can just discuss about that, because I'm saying that I'm calculating with you.
but to find the mass, isn't it the number of atoms divided by Avogadro's number?
Okay, so
Doctor,
yes.
yeah, I need to ask you about if you can give us about the molar mass in the exams.
Okay, so I already discussed it last time. Everything is uploaded on Moodle. Okay, so and we discussed some practical questions, and this is also practical questions which I gave you at home. So you could just, if you check these files, this file, you could find this slide over there, and you could look at this one and practice at home. But everything is uploaded, okay, on Moodle, so you can check it in there. By the way, next week we'll have a quiz, and quiz will be related to the same topics as this one. Okay, so like Avogadro's number, mole, molar mass, number of atoms, so things like this. So you need to check these slides. Okay, you can check it also in the book if you want. I send out the book, but you can also check these slides, and you can check these recordings which I uploaded. Okay, so how to find molar masses? There's a periodic table. You can check periodic table. You can find molar masses of everything you want, any chemical you want.
Okay, Doctor.
Okay.
Yeah, you need to upload this lecture.
I'm uploading every lecture we have here. I'm uploading every lecture we have here.
I told
you, yeah. So why are you asking that? So I told you that.
But I ask about
Okay,
this.
excuse me. Let me finish. Let me finish. If I don't record something, please remind me to record it. Okay. And if I don't upload something in 2 days, say 1 or 2 days, again, send me an email to remind me to upload the lecture or PPT files. Okay. because sometimes
Okay,
I
that's good.
might either forgot or some other reasons. But please remind me about that. All right, so let's just. Did you guys understand this, or you didn't get the point here?
Yeah, that's
Sure,
clear.
I
I
did this
understand it.
calculation, but without the 12. Like I just put the 3 times 10 to the power of 17 divided by the Avogadro's number.
So if you get a tiny pencil mark just visible to the Greek column. So if you divide this by Avogadro's number, then you will get maybe amount of moles. You can find like how much moles you can get, but then you need to multiply it by 12. You can find maybe number of moles, but it's
Isn't the moles, don't we divide mass over molar mass to find the mole?
to find the moles, yes, you need to divide mass over molar mass. Yes, and you
And to
find
find the
moles.
mass, and to find the mass of a molecule, you divide the number of atoms by the Avogadro's number.
Yeah,
So I
then
don't
you
get
need.
why did you add the 12 with the
Okay,
3
so
times 10 to the power of 17?
You need to so only by dividing number of atoms by. Okay, let me do it again. Let's just discuss in a different way. So 1 mole of carbon. How many atoms are in 1 mole of carbon?
12, Carol.
No. I'm talking about number of atoms. How many atoms are in 1 mole of carbon?
Avogadro's number.
Yeah, so it's 6.022 times 10 in power 23, right?
Yes.
Now I have a question. How many moles of atoms would be, how many moles would be in 3.10 in power 17 atoms?
So you divide it by the Avogadro's number.
Yeah, you divide 3 times 10 in power 17 by Avogadro's number, right?
Yes.
This is what you did, right?
Yeah.
So by that, you will find number of moles, but not mass. Did you get the point?
Yes.
Okay, so let's just write it. So X moles will be 3 times 10 in power 17 atoms, okay? So by finding X, you will find moles, but you will not find mass. To find the mass, then you need to multiply X, whatever you get, so it's moles, right? X is moles. So moles multiplied by molar mass, which is 12 gram per mole, okay? So mole and mole is gone and you end up with grams, okay? This is X grams. X moles, I'm sorry, this X moles. Did you get the point?
Yes.
Okay, so this is why we multiplied by 12. Is it clear now? Okay, let's just see the second and the third question. I want you to think about. I'll delete this one if you want, or I can just copy this if you want to keep it. For example, 1 second, please. Yeah, if you want to keep these notes, I can just copy it and let's delete here and let's delete here. Okay, and now think about that's question number 2. What do you have? What do you need to find out, and so on?
So you get the molar mass.
Yeah. So first
And
of
you
all, you need
divide
to.
mass by molar mass.
Yeah, so let's just, can you finish it like calculation and everything?
Yes, it's 0.70 moles of zinc.
Okay, so we have, so we need to find how many moles of zinc we have, right? So we have mass of zinc. We need to find moles of zinc. So what is the molar mass of zinc?
65.38.
So it's 65.38, right? So I'm not checking that, I'm just trusting you. So yeah, it's about that one. Gram per mole. We should not forget about the unit. It's gram per mole. Now, to find the moles, you just need to divide this by this. So if you divide 45.9 gram over 65.4, say, gram per mole. So what is the number here?
0.70.
0.17, right? You say
70.
70. Okay, 70. Okay, thanks. So this is what is the unit for this?
Moles.
Right, exactly. It's gonna be moles. Moles. Okay, so it's clear this one, right? So now let's just finish with the last one here, this one.
Do you use Avogadro's number times the 25.1 gram to
Let's
find the number
see.
of atoms?
Yeah, let's see. So sulfur is a non-metallic element that is present in coal. When coal is burned, sulfur is converted to sulfur dioxide and eventually to sulfuric acid, which gives rise to the acid rain phenomenon. How many atoms are in 25 grams of sulfur? Okay, so how to find it? How many atoms?
Avogadro's number times the mass.
So definitely we need Avogadro's number. Definitely we need
But
Avogadro's
I'm
number.
not sure if we have to use the molar mass.
Yeah, so this is what you need to find out. So you need to think about that. Think a little bit about that. Okay, so if you take Avogadro's number of sulfur, what's going to be the mass of that amount of sulfur?
You'll need the molar mass to calculate it.
Yes, you just need to know what is the molar mass, right? Okay, if I tell you that molar mass of sulfur is 32 gram per mole, so okay, so now you know what is molar mass of sulfur. Can you tell me what's gonna be the mass of sulfur, which is equal to Avogadro's number of atoms?
You need the moles.
Okay, so how many moles you have if you have Avogadro's number of sulfur or anything?
So 25.1 divided by the molar mass, which you said is 14, I think.
Yeah, so but let's just answer the question. So how many moles you have of sulfur if you have Avogadro's number of sulfur?
Zero point 0.7.
How did you find that one? Okay, so I see that you still do not have really solid understanding of that. I strongly recommend you to go back and review what we discussed last time, because I don't see that you guys are getting something, but not really understanding everything like completely. Okay, so let's just go back. You need to read this slide. Okay, let's just see this slide. See here, this one, for example. Read this one. Okay, now read this one completely, this one, everything. Read it carefully. So now I want you to answer the question I just asked. So if you have Avogadro's number of sulfur and you know that molar mass of sulfur is 32 grams per mole.
32.
So the mass of that one is going to be 32, right? But how many moles of sulfur you will have if you have Avogadro's number of sulfur? Okay, so I say that molar mass of sulfur is 32 grams per mole. You say that and you answer that if we have Avogadro's number, it means that we have 32 grams of sulfur. At the same time, we know that our molar mass of sulfur is 32 grams per mole. So if I have Avogadro's number of sulfur, how many moles of sulfur I will have? Can you just take a pen and a pencil? I'm sorry, pen and a paper.
Is it mass over molar mass?
No, wait a second. So take a pen and take a piece of paper. So if it is a little bit difficult, so take a piece of paper, take a pen and write. So Avogadro's number means that you have 32 grams. Write it down. Now write that molar mass of sulfur is 32 grams per mole. Right? Did you write it down? So it means that 1 mole of sulfur, write it also down. 1 mole of sulfur is 32 grams. This is what does it mean. Now, if you look to all this, what you wrote down, now I have a question. What's going to be the number of moles of sulfur if you have Avogadro's number of sulfur? Think about that one.
We have 1.
Yes, you will have 1 mole of sulfur. So whatever you take, I told you last time, so I think you didn't listen or you didn't watch the recordings again. Remember it forever. Whatever you take Avogadro's number, it means that you have 1 mole of that something. Okay, so we are talking about chemicals, so it means that it's about chemicals, right? We don't care about like tables or cell phones, right? So it means that you have 1 mole of that substance, either it's molecules or atoms, right? Or ions. Ions, we'll talk about that. It means that you have 1 mole of that if you have Avogadro's number. Okay. Now let's just look at our question. Now the question is how many atoms are in this amount of sulfur, and basically we answered that one, but let's just again finish it. Oh, sorry, let's just finish it. Okay, so what's going to be the answer here?
1.2. Yes.
No, it cannot be 1.2. So look, I told you that Avogadro's number is 32 grams, right? And you have 25 grams.
Yes.
So you need to find atoms. So, okay, I told you that one Avogadro's number, which is 6.00.
Doctor, excuse me.
Yeah.
The molar mass 32, it's a real or just example?
No, it's a real one. 32 gram per mole. It's a real one. So what did we say? How much is this one? How much sulfur you have if you have Avogadro's number?
32.
Yeah, so we have 32 grams, right? So this is what you
Yes.
have. Now you need to find this amount. How many atoms you will have in this amount of sulfur? What do you need to do? Okay, so you need to think like this way. Will you have more or less than Avogadro's number of atoms?
Less.
Doctor.
Less, right? Yeah, so that's
Yes.
true. Now think how less. So the strategy is that, okay, so you know this is 32. So you have 25.1 grams. So it's going to be X. Okay, that's the easiest way to approach this problem. Now you need to find X. Did anybody find it?
Doctor, X will be 4.7.
X would be what?
4.7.
4.7? No. It's impossible. No.
Seven point six.
No.
4.7 times 10 power 23.
Power 20. It's kind of close. Let's just see. So basically, X is going to be divide 25 by 32.
Say it again, doctor.
Divide 25 by 32. 25.1 by 32. Yeah, so the last answer is also not right. So divide 25 by 32, please.
1.2.
25 by 32. 25 divided by
0.78.
32. Yeah, it's
0.78.
0.78, right? Okay. So 0.78 times 6 power 22 power 10 in power 23. This is the amount of atoms you will have. Now multiply 0.78.
4.69 times 10 to the power of 23.
Exactly. So 4 point what?
69 or 7.
Okay, okay, 7. 4.7 times 10 in power 23. Now let's just look to our discussion. We said that it's going to be less than Avogadro's number, right? This is what we said. Is it less than Avogadro's number or it's more than Avogadro's number?
Less.
Of course it's less. So we kind of what we assumed, what we thought about, so our result basically confirms it. So this is what we expected. So you need to always check your expectation after you got result. You always need to check it if it makes sense or not. So definitely it makes sense, but again you need to double check if it is exactly what you are supposed to get. Okay. Again, so you should not leave your answer without checking. This is in general, it's not only in this class, but especially for people who are going to work in the field of medicine, they need to double check always what they are getting. All right, so I think this is clear. So you practice again at home these kind of examples, and then you will have a quiz on next week. It will be on Moodle, and it will be short quiz. It will not be long quiz because there will be just maybe 3 or 4 questions like this. Okay, and
Sir, will there be any more practices for these kind of problems?
okay, so I think that this is enough practicing for this kind of. We are practicing for the whole like hour, and this is basically if we. So we checked everything. Like we practiced on finding the mass. We checked finding the mole. We checked. We practiced finding the number of atoms. Do you see that? We checked like mass. We practiced the moles. We practiced how many atoms. So we practiced all these 3 parameters which are interrelated. So this is absolutely enough, I think, for the class practicing. Okay, if you want to practice at home, you can just see some questions in the book, or yeah. So if so if you want to like make it better. Also, we practiced some last time, for example, here. So we also practiced here sometime, right? Some kind of two more examples were here. I think this should be enough. This is not very complicated stuff that we can spend here like several classes. It's impossible. So we need to catch it quickly, okay? And then we need to go forward. So it will not be long quiz. You will see it on Moodle. Maybe I'll give you, if there are like 3 questions, maybe I'll give you only 15 minutes or 20, not more. So you have to be very well prepared to finish the work. Okay. Then we'll have a class after quiz. All right.
Excuse me, Zakir.
Yes.
All question wanna be a multiple choice question, or we have to
Yeah,
describe
so
it?
I'll see. It might be multiple choice question, it might be like open question. Like, I mean, anyway, you will have something like this, but you will need to write your explanation. Yeah, so it might be maybe one question multiple choice, the other one like open question. You need to show the calculations.
Okay, thank you.
Yes.
Next week is holiday or no?
Say it again, please.
Next week is holiday.
Yeah, so I think next Monday is day off. Oh yeah, right. So next Monday, I think it's day off, but I'll check with office to make sure. So because we have Easter holidays and usually the next day is day off after Sunday. So I'll check with office about that. I'll let you know if it is day off. So I'll let you know about that. Okay. I have only like about 1 minute left, but after this is off, we need to come back and continue. Okay. So everything is clear here.
Yes, doctor.
All right, good. Now I will share another screen, and then once the Zoom is off, I'll just basically start it again. Okay. We stopped last time here, I believe, right? We were discussing about how to balance equations. What does it mean, this
Yes,
coefficient?
doctor.
Right.
Yeah.
So what does it mean, these coefficients in front of these molecules, right? So this is what we discussed. And this is basically the same, so just more maybe clear. So you can see the number of moles of hydrogen. So this is 3 moles of hydrogen, 1 mole of nitrogen. We don't write 1, but we think that this is 1, and then we get 2 moles of ammonia. So all these coefficients are considered as moles. And for example, overall here we have 6 atoms of